Algebra 1 students, welcome to your 2.5 notes. Today we're going to take a look at literal equations. The title also includes the word formulas. We'll actually save that for the second half of this section. Really interesting topic, has some applications to the worlds of science and other places. Hopefully you can pick up what we're doing today. So let's get started. All right, for our first set of problems, our instructions say to solve each equation for y, then find the value of y for each given x value. So we're going to look at number one. If I want to get y by itself, I need to subtract x from each side. So we'll have y equals, you could write this as 18 minus x or negative x plus 18. It's your choice. All right, that's the first part. That's easy. Now what we need to do is go ahead and evaluate for these three different values of x that you see over here. So the first one at negative 3, we could say y equals 18 minus negative 3. And that, of course, would give us 18 plus 3, or 21. And we would continue on and evaluate at the other two values as well. For 2, we'd have y equal to 18 minus 2, which would be 16. And then finally for 5, y would be 18 minus 5, or 13. All right, so we're going to do the same thing on the next set here. We'll start by solving for y. Now this one, there's a little more work to solve for y, still not too bad. Add 7 to each side. And I'm going to kind of switch the order of these two. I'm going to go ahead and move the 5y to the other side. So 5y equals 2x plus 7. And then, of course, we'd have to divide everything by 5. So our equation will look something like y is equal to 2x plus 7 over 5. Now we could separate that and make it 2/5 x plus 7/5, but I'm actually just fine leaving it the way we have it here. It might be easier for us to evaluate, which is what we're going to do. So let's start by evaluating at 0. We would have 2 times 0 plus 7 divided by 5, and that is just simply 7/5. For 2, we'd plug in 2 for x, so we would take 2 times 2. We'd still add 7 and divide by 5. That's 4 plus 7 divided by 5, so that's 11/5. And then finally with 4, we'd have 2 times 4 plus 7 divided by 5. That's 8 plus 7, or 15/5, and that then would be 3. All right, so what we're actually doing here is solving these equations as if they're literal equations, and we'll look at that definition in a little more depth in a moment. This is a nice way if we have to plug in multiple values. You solve first, and then you can work from there. All right, pause the video, do number 3 on your own, and then compare your answers to mine. Welcome back. You can see my solutions here. First, as the instructions called for, we solved for y. I found that y was equal to negative 5 plus 3x, which I prefer to write it as 3x minus 5, although either way would be totally fine. And then you can see I plugged in the 3 given values, negative 2, positive 2, and 6, and got the results that you see there. All right, so there's a little bit of work on these, but the main thing is, can you solve for y? If you can, plugging in numbers, not too big of a deal. All right, a couple of definitions for you. A literal equation is an equation that involves 2 or more variables. Okay, so a literal equation, 2 or more variables. That's what we've been working on. As a matter of fact, the part of the section 2.5 that we're working on today will focus exclusively on literal equations. A formula is an equation that states a relationship among variables, or I'm going to write it as among quantities. Now we'll deal more with the formula side of this in a few days. For now, we will just stick with the literal equations. So let's do this. It's basically just algebraic manipulations. Here we go. Solve for x. You guys have seen this before, y equals mx plus b, but now our instructions are to get x by itself. So let's start by subtracting b. And then you can see we have mx equals, and if I want to get x by itself, I divide both sides by b. So you could write your answer as y minus b over m equal to x. You could separate it and do y over m minus b over m equals x. That would be perfectly fine. All right, same instructions for number 5, a little more work. Now, what I would advise is on this one, let's distribute. So 7x equals 3x plus 6y. So I've taken that 3, multiplied it by x, and by 2y. Now let's get the x terms together. In the end, we're trying to get all the x terms to one side isolated, so we only want to have the x terms together. So 4x equals 6y, and then of course the last step is divide by 4, and I'm going to go ahead and simplify that. 6 over 4 is the same as 3 halves y. All right, we have one more on this slide. It's a different format, looks a little different, but it's the same kind of idea. We're going to get x by itself. This is when we use what's called the cross products property. So we would know that q times s is equal to x times r. Now again, our job is to get x by itself. I've got x multiplied by r. I need to undo that by dividing, and this one worked out real quickly. X is equal to q times s divided by r. All right, same instructions. Here we go. PV equals nRT. This is a gas law formula that you might learn in a chemistry or physics class later on. But we're being asked to solve this for r, the variable r. Now, really, this is a pretty simple equation. That's multiplication, and that's all multiplication. So all I'm going to do is divide by n on both sides. So PV over n. As a matter of fact, let me do something to simplify this for you. Instead of doing this in 2 steps, let's do it in 1. Let's divide by n and t, and we'll have PV over nt equals r. Then we're done with it. 1 step. Okay, next one. As a matter of fact, why don't you pause the video again and you do number 2, and then we'll do number 3 together. Okay, you can see what I did on number 8 now. Subtract ax, that got the by term by itself, and then divided by y because we were trying to solve for b. All right, one more, number 9, and I found a small error on my problem. This v right here should be lowercase. I'm not sure that'll bother you, but it bothers me, so I'm going to fix it. All right, here we go. 3w minus 3v. You know what property that is, I do believe. The distributive property is equal to 4v minus 5. Now we have to keep in mind what we're doing here is solving for v. I need to get all the v terms together on one side of the equation, and I need to put everything else on the other side. So I'm going to start by adding 5 to each side, and you could switch the order on this a little bit. It would work just fine. And now I'm going to add 3v to each side. And we're almost there. Last step, divide both sides by 7, and you'll have your v value isolated. So 3w plus 5 divided by 7. All right, students, that's a wrap on your 2.5a notes. If you've taken good notes, you'll be coming to class ready to work and get an assignment done, and then we'll finish out the rest of this section in the days to come. You guys have a spectacular day.